Welcome to AI Frontiers. Today's episode embarks on an in-depth journey through the evolving landscape of contemporary software engineering by synthesizing insights from 4 influential research papers, each published on May 8, 2025. Together, these works illuminate the direction in which the field is moving, highlight the most pressing challenges, and showcase how researchers and practitioners are proactively responding to rapid technological change. As today's discussion unfolds, complex concepts will be broken down into accessible insights, ensuring that both seasoned software professionals and enthusiastic newcomers can fully appreciate the significance of these developments. Recent breakthroughs in software engineering are explored, with a focus on understanding the challenges, emerging solutions, and anticipated future directions that shape this essential discipline. To provide context, software engineering is introduced as a specialized field within computer science, dedicated to the systematic design, creation, testing, and ongoing evolution of software systems. This discipline does not focus solely on technical elements. Instead, it balances technical, human, and organizational factors to address a wide spectrum of concerns, including system design, rigorous testing, long-term maintenance, legal compliance, and user-centric needs. The field enables the continuous evolution of software to meet changing requirements in a dynamic digital environment. Software engineering is, therefore, not just about writing code, but about architecting resilient systems, managing complex projects, and ensuring that software meets both functional and societal expectations. The rise of artificial intelligence in software development underpins the first major theme: automated code generation and validation. Large language models are now increasingly capable of generating software code, yet concerns about their reliability persist. A particular issue, known as API hallucination, occurs when a model invents or incorrectly applies programming interfaces, leading to non-functional or insecure code. Chen and colleagues address this challenge with the introduction of MARIN, a hierarchical dependency-aware framework designed to mitigate API hallucination. Such innovations are pivotal, as the safe and effective adoption of AI-assisted development tools depends on the implementation of robust validation mechanisms to ensure code correctness and reliability. The second dominant theme centers on benchmarking the performance of code language models. Wang and colleagues conducted a comprehensive survey of 181 benchmarks used for evaluating code generation models. A key finding is that most benchmarks are concentrated on the code implementation phase, with far fewer assessments addressing the design or requirement stages of software development. This imbalance underscores the necessity for more holistic evaluation frameworks, capable of spanning the full software lifecycle. Effective benchmarking not only guides the development of superior AI tools, but also ensures that such tools support a broader set of engineering activities beyond mere code production. Feature management and code quality are highlighted as a third critical theme. Feature toggles, mechanisms that enable teams to activate or deactivate software features dynamically, are powerful for facilitating updates and experimentation. However, poor management of toggles can introduce maintenance challenges and degrade overall code quality. In response, Raman and collaborators developed cs.SE, an automated tool designed to identify problematic toggle usage patterns, commonly known as toggle smells. The deployment of such tools assists developers in maintaining cleaner, healthier code bases, thereby reducing technical debt and supporting more agile and reliable software evolution. The fourth theme explores the intersection of privacy, compliance, and model-driven engineering, particularly in the context of wearable technology. As wearables increasingly collect sensitive user data, privacy concerns have become paramount. The introduction of reusable, legally vetted privacy models, such as those described in the 4th research paper, facilitates compliance with evolving legal frameworks and streamlines the integration of privacy features into software products. Model-driven engineering techniques further support consistency and reusability, ensuring that privacy policies are clear, accessible, and capable of building trust with users. This approach is essential for maintaining ethical standards in modern software systems. Across these research contributions, several key findings and practical breakthroughs emerge. ts.SE, developed by Raman and colleagues, demonstrated an 86% accuracy rate in detecting nested toggle smells, facilitating proactive code quality management. Wang et al. Found that 60% of surveyed benchmarks focus exclusively on the code implementation phase, revealing a critical gap in comprehensive evaluation across the software development lifecycle. The MARIN framework, introduced by Chen and colleagues, achieved a reduction of over 67% in API hallucination rates, significantly improving the reliability of AI-generated code. Additionally, the creation of legally vetted privacy models for wearable devices simplifies regulatory compliance and enhances user trust. Collectively, these breakthroughs illustrate the tangible impact of targeted, context-aware solutions in advancing software engineering practice. Turning to the methodologies underpinning these advances, a diverse set of techniques is observed. Static code analysis, as exemplified by cs.SE, enables the efficient scanning of large codebases for patterns and anomalies. Manual validation augments automated results to ensure tool accuracy and reliability. Comprehensive benchmark surveys, such as those conducted by Wang et al., map both the breadths and gaps in research coverage. Model-driven engineering guides the integration of privacy and compliance features, offering structured, reusable approaches to complex requirements. Finally, dependency mining, central to frameworks like MARIN, constrains AI outputs to valid project dependencies, thereby enhancing the safety and reliability of automated code generation. Each methodology contributes uniquely to the robustness and innovation observed in current software engineering research. A deeper exploration into Rahman et al.'s paper on feature toggle detection reveals a significant contribution to code quality assurance. cs.SE is designed to identify 5 types of toggle smells: spread, nested, dead, mixed, and enum, across 6 programming languages. By combining static analysis with rigorous manual review, the tool achieves high true positive rates, particularly for nested and spread toggles. As an open-source solution, cs.SE empowers agile teams to proactively manage feature toggles, maintain high code quality, and streamline continuous development workflows. The practical impact of this research is evident in its applicability to real-world codebases, where the early detection of toggle smells can prevent technical debt and support scalable software evolution. Wang and colleagues' work on benchmarking code language models offers an expansive survey of the state of intelligent development agents. The study reviews 181 benchmarks from a total of 461 papers, revealing that the majority of benchmarks are concentrated on code implementation tasks, with significant neglect of design and requirements engineering phases. This finding points to the urgent need for more holistic and diversified benchmarks, capable of evaluating AI tools across a broader range of programming languages and development stages. The roadmap provided by this research sets the stage for future standards in evaluation, ensuring that code language models can be assessed for their comprehensive utility rather than their proficiency in isolated tasks. This paper has been selected for its thorough mapping of the field and its influence on the assessment of AI-driven development tools. The paper by Chen et al. Addresses the critical issue of API hallucination in AI-generated code by introducing MARIN, a hierarchical, dependency-aware code generation framework. MARIN systematically analyzes both local and global code dependencies, thereby constraining language models to utilize only valid project APIs. This approach reduces API hallucination rates by over 67% in leading models, as validated through both real-world projects and new benchmark datasets. The framework's effectiveness in practical settings demonstrates its value in overcoming a key barrier to the trustworthy adoption of AI coding tools. MARIN's integration of dependency mining into the code generation process is central to enhancing reliability and fostering greater confidence in AI-assisted development. Looking toward the future, several priorities are identified for software engineering research. There is a pronounced need to develop holistic benchmarks that encompass the full software development lifecycle, ensuring balanced evaluation of AI tools. Enhancing tools capable of managing dynamic, complex systems through methods such as hierarchical analysis remains essential as software grows in scale and interconnectedness. The integration of evolving legal and ethical frameworks into everyday engineering practice must continue, supported by accessible compliance models. Education is highlighted as a key factor, empowering developers to effectively adopt and utilize AI tools, while best practices and training ensure sustained success. Finally, fostering collaboration between technologists, legal experts, and end users is vital for the responsible and effective advancement of the field. A technical concept central to many of the studies discussed is static code analysis. This technique involves the examination of source code structure without executing the program, enabling tools to efficiently scan for patterns, errors, or code smells across large multi-language projects. Static analysis is invaluable for automated quality assurance, providing scalable coverage while minimizing manual review. However, it is important to note that static analysis may miss certain runtime or context-dependent issues, underscoring the need for complementary methodologies such as manual validation and dynamic analysis in comprehensive quality assurance strategies. Dependency mining, another pivotal technical concept, is particularly relevant in the context of AI code generation. This process involves analyzing the relationships between functions and application programming interfaces within the codebase. By constraining AI-generated code to utilize only valid project dependencies, dependency mining plays a key role in reducing hallucination errors produced by language models. Frameworks such as MARIN, developed by Chen et al., leverage this technique to ensure that AI coding assistants generate reliable, context-appropriate code. The increased trust resulting from dependency-aware outputs is fundamental to the broader adoption of AI tools in software engineering workflows. The synthesis and review presented in this episode were created using advanced artificial intelligence models and rigorous expert validation. Content summarization and narrative structuring were performed using OpenAI's GPT-4.1 model, ensuring clarity and technical precision. Text-to-speech audio was generated via DeepRam, with suggested visuals produced through Stable Diffusion. All research summaries have been subjected to human expert review to enhance accuracy, though some minor oversights may remain. Listeners seeking further detail or verification are encouraged to consult the provided references for deeper study. For ongoing exploration of artificial intelligence and computer science research, AI Frontiers invites listeners to subscribe for additional deep dives and up-to-date insights. Regular coverage of the latest breakthroughs ensures that subscribers remain informed about the most impactful developments in the field. To stay connected with current trends and discoveries, follow the AI Frontiers channel. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.